In this video, we're going to start Chapter 10, which is all about intelligence. Part 1 is going to be us talking a little bit about what intelligence is and how people have gone about measuring intelligence in the past. So step 1 is, what actually is intelligence? And this is a tricky question to answer. As we talk through this chapter, we're going to start realizing that there are a lot of different ways to define intelligence. And in particular, there are a lot of cultural differences in how we view intelligence. For example, in Western cultures, intelligence could just be seen as good mental skills. But more broadly, others might start bringing in the idea of a good ability to respond adaptively to your environment. Can you adjust your behavior accordingly when faced with changes in your environment? And when we start talking about cultural differences and how different people all around the world view intelligence, we're going to start realizing that our standard Western interpretation of intelligence as good mental skills doesn't necessarily hold up in other areas. With that vague description of what intelligence might be and how fluid it can be, the definition that we're going to use for intelligence for now is the ability to acquire knowledge, to think and reason effectively, and to deal adaptively with the environment. That seems to encompass quite a few parts of intelligence. So let's move on with that. We're going to start with sort of a historic view of how we've gotten to the point that we are at now with intelligence evaluations. And our starting point is going to cover two historical and somewhat opposing views on mental skills. So we have Sir Francis Galton and Alfred Binet, both of whom contributed to the field of studying intelligence. But let's start with Sir Francis Galton. Now, this name may have been familiar to you even before you started learning about intelligence. And that's because Sir Francis Galton was quite the accomplished scientist, philosopher, inventor, all sorts of things. The short list of his accomplishments include the fact that he came up with a method for classifying fingerprints, which has led to how we use fingerprints today for crime and victim identification and things like that. He was a pioneer of eugenics, and he actually came up with the term eugenics back in the late 1800s. He is the one who started using the phrase nature versus nurture, building off of his cousin, Charles Darwin's theory of evolution. He's a founding member of psychometrics, which will come up later in this chapter, but psychometrics is the science of measuring our mental faculties. He came up with some theories or hypotheses of personality, and he wrote a book on hereditary genius, which is why we're talking about him now. So he was a very accomplished man. So even though in the textbook he's listed as Charles Darwin's cousin, and strongly influenced by Darwin's theory of evolution, there's a lot more to Galton than what you might have expected on the surface. So we care about Galton because he actually researched intelligence. He used his book, Hereditary Genius, which was published in 1869, to try and study genius through different family lines. So he was studying the inheritance of intelligence, effectively. And he was specifically interested in eminence and genius, so the link between being successful and being intelligent. From his investigations of family trees full of eminent and also intelligent people, he concluded that mental ability is inherited. That people in those eminent families, that people who came from families that were very successful and usually wealthy, ended up being more intelligent. Now, we might look at this and think of it as flawed logic because these eminent people were also coming from privileged environments. So there's an environmental factor there that he completely ignored. But he dismissed that entirely and decided to spend a good chunk of his life trying to show this link between your social status, your success in life, and different measures of mental ability. Now, he called these measures a means of getting at the efficiency of the nervous system. So he wanted to see if those people had more highly functioning nervous systems. And so he looked at things like reaction speed, hand strength, visual acuity, and even started measuring people's head size to try and get an approximation of brain volume. The idea here being that people with larger heads would have larger brains and should therefore be smarter. The downside to all of this is that there wasn't any clean correlation between these measures of efficiency of the nervous system and socially relevant measures of mental ability, things like academic and occupational success. But we still talk about Galton because he created an interest in this area. He got people curious about things that could tell them about intelligence, things that were measures of intelligence. And that set the stage for our second researcher, who's Alfred Binet. Now, Alfred Binet came onto the stage a little bit later on, around the turn of the 20th century. And he had trained with Galton, but he had a very different perspective from Galton. So where Galton had wanted to find this link between eminence and genius, Binet had a much more practical idea in mind. Binet was a French psychologist who had been hired by the Ministry of Public Education to try and develop some kind of test of intelligence. And this test was going to be used to try and identify children who weren't benefiting from normal public schooling. He wanted to identify children who were struggling in the public school system so that he could arrange specialized learning that would help cater to their needs. And this idea of mental testing is what led into our modern intelligence testing movement. This was the beginning of it, where you could test large numbers of people and sort of get an idea of where they stood in terms of mental intelligence. Now, Binet started his work with two basic assumptions. The first of these is that mental abilities develop with age. So a 3-year-old is probably more advanced mentally than a 2-year-old. The second point builds off of this, stating that the rate at which people gain mental competence is characteristic of the person and is constant over time, which is a fancy way of saying that people are going to grow and gain in that mental competence over time, and that there should be a pretty much constant rate of change. And so what we can take from this is the idea that someone who is maybe behind the curve in mental intelligence at the age of 5 would probably still be less intelligent than average at age 10. And same works on the opposite side of things, where if you are above average in intelligence at a younger age, you should still be above the average in intelligence at a higher age. So Binet sat down and interviewed a bunch of teachers to try and determine what kinds of problems children could solve at different ages. So he would talk to teachers that taught 5-year-olds, he would talk to teachers that taught 8-year-olds, so on and so forth, to try and figure out which problems were solvable by one age group but not the other. Where were those cutoffs, and where should students be at a particular age? And he put all of his gathered information together to develop a standardized interview. He put together a bunch of questions where he could figure out if a child was performing at the correct mental level for their age. And this came to give us the concept of mental age. So an 8-year-old with average intelligence would have a mental age of 8. But an 8-year-old that scored high on Binet's test could be said to have a mental age of 10. They were as intelligent or as mentally capable as a child of the age of 10. Now, what kinds of problems, what kinds of abilities would be used to tell the difference between the different ages? We can actually look at a couple of highlights from each of these. So we can look at age 3 and 4 here. So by the age of 3, a child should be able to point to objects that serve various functions. So if they see a pair of shoes, they should be able to identify that those go on your feet. They should be able to name pictures of objects, things that they would use, like a chair. And they should be able to repeat a list of 2 words or digits. So if you're given dog and boy, they should be able to repeat that back. And then these abilities should be scaling up as the child gets older. So by age 4, they should be able to tell the difference between visual forms. So can they tell a square from a circle, from a triangle? Define simple words, usually things that they use, like a ball or a bat. Repeat much longer strings of words, so 10-word sentences. Count up to 4 objects. And then even get into some simple problem solving. And we can continue up this scale. So by age 6, they can tell the difference between similar items. Maybe they can tell animals apart. Count up to 9 blocks. Solve more complicated problems. And then by age 9, we get into more elaborate verbal problems, then simple arithmetic problems, and repeating 4 digits, but this time in reverse order, so adding that extra complexity. And the last one we'll look at is by age 12, they should be able to define more complicated words, and the example they used was muzzle. I don't know if 12-year-olds today could do that, but we'll see. Repeat 5 digits in reverse order, so scaling up difficulty by including extra items. And solving verbal absurdities, such as, Bill's feet are so big he has to pull his trousers over his head. What is foolish about that? So there has to be some logic involved and some understanding of what's going on. So there are lots more points for each of these, but these are good highlights to give you an idea of how these increase in difficulty as children age. So their abilities should get better with age. Now we can build on Binet's concept of mental age and actually see how people took his idea and started running with it. So the first person that picked up on Binet's idea was the German psychologist William Stern. Now Stern decided to produce, or to come up with a method to produce, a relative score of intelligence, a quotient of intelligence. And he wanted to make sure that it wasn't just reliant on chronological age. So he didn't care that you were an 8-year-old with the mental age of 10. He wanted some kind of relationship, some kind of number that would report how far above or below the average intelligence for your age you were. And so he came up with a ratio of your mental age to chronological age. So he actually invented the intelligence quotient. And I decided to look it up because I've been using IQ as a term for so long, and I know that it's a quotient, but I hadn't really realized what a quotient meant. But a quotient is simply a result obtained by dividing one quantity by another. Fairly simple. So this quotient of intelligence is obtained by taking our mental age, the MA, and dividing it by your chronological age, CA, and then multiplying by 100 to give a more workable number. So if your mental age and chronological age are the same, so if you're an 8-year-old with the mentality of an 8-year-old, your IQ is 100. You are performing average for your age. A child with a mental age of 10, but a chronological age of 5, is going to have an IQ of 200 because their mental age is much higher than their chronological age. And you can plug all sorts of different age combinations in here, comparing mental and chronological age. But the main idea is that if your mental age is higher than your chronological age, then your number should be above 100. And if your chronological age is the larger one, then your number should be less than 100. So this allows us to apply this idea of mental and chronological age to people of different chronological ages. We weren't stuck to just the ages that Binet had looked at when originally setting up his questions. And I should take a moment here to point out that the modern idea of IQ doesn't use this same setup. So the modern tests don't really use the idea of mental age versus chronological age. And the reason why they stopped using this specific equation is that most of the skills required for these tests were learned by the age of 16. So the equation stopped being as effective as people got older than 16. You also run into the extra problem of the fact that certain intellectual skills decline with age after a certain point. So once you pass the age of 65 or 70, your mental faculties can start declining again, which could mess up this kind of an equation. So modern equations don't use the same basic idea as here, but they're founded on the same concept. I just think it's interesting to note that a modern IQ test isn't actually a quotient at all, despite the name. Our next person who built on this idea is going to be Louis Terman. Terman was responsible for importing Binet's intelligence test to the United States. So if you remember, Binet had originally designed all of this to work in France, and so it was all written in French. So Terman brought it to the US, translated it to English, and rewrote the questions to better apply with American culture. So this is our first indication that there is a cultural aspect to these tests of intelligence, which is very important later on in this chapter. And so this revised test was called the Stanford-Binet test, or the Stanford-Binet scale. And the reason that Stanford has suddenly appeared in the name here is because Terman was working at Stanford at the time. But this Stanford-Binet scale quickly became the gold standard for measuring mental aptitude. It contained mostly verbal items, and it gave us a single IQ score, so it would pump out a single number that you could quantify a person's general intelligence with. And so this Stanford-Binet test became the standard for all future individually administered intelligence tests. And we still use a variant of it today for most IQ testing. Fairly early on, this Stanford-Binet test was adapted when the US entered World War I. The Army wanted a sort of quick and easy way to screen large numbers of recruits to evaluate their mental capacity. They were looking for the intellectual fitness of people who were joining the Army. And so this first test became Army Alpha. And it was a mostly verbal test, very similar to the original Stanford-Binet test. And this adjustment was done by one of Terman's students, so keeping it in the family there. But they very quickly realized that not all recruits were able to read. There were a lot of people that were being excluded by the original Army Alpha test. And so they made a non-verbal equivalent called the Army Beta. And it made use of mazes, picture completion problems, and digit symbol tasks, things that you could understand without having to be able to read the words used in the original Army Alpha. Now, as we often see throughout history, when one thing evolves or comes to exist in society, there's usually a counterpoint that pops up soon after. And this was the same with our Stanford-Binet test, where soon after, about 20 years later, after this Stanford-Binet scale had been established, David Wechsler, another researcher, decided to come up with a competitor for the Stanford-Binet test. He believed that the Stanford-Binet test relied too heavily on verbal skills and wanted to come up with a method of testing both verbal and nonverbal skills. And so these ones might be something that you're familiar with. Maybe you've heard of the WAIS, the Wechsler Adult Intelligence Scale, that was developed originally back in 1939. Then we have the WAISC, the Wechsler Intelligence Scale for Children, which was developed in 1955. And then the Wechsler Preschool and Primary Scale of Intelligence, WPPSI, doesn't have a nice short form, in 1967. So fairly quickly after each other, considering the scale of these different tests, these were released. And so from the names, you can tell that our WAISC, the first one here, was designed to test adult intelligence, so as a stand-in for the Stanford-Binet. But then there were also adaptations made to test intelligence in children, and then even younger children for the primary school one. And these tests are, again, still used today. So they are on the WAIS version 4 and the WISC version 5. So those are still actively used today as a lot of standardized tests for intelligence. And we do still have a modern version of the Stanford-Binet test. So the current version, the one that you'll see nowadays for Stanford-Binet, has also been revised to look at more than just your verbal intelligence. It'll also look at nonverbal skills, but originally that's not what it was doing. So if we can look at our summary here of the two types of intelligence tests when they were proposed, the Stanford-Binet focused mostly on those verbal items, and it gave you a single IQ score, which was very useful. Our Wechsler tests were different because they came up with a series of subtests. So it wasn't just one single test that gave you one number at the end. There were also different things that you could evaluate, sort of sub-breakdowns of intelligence. And they had verbal tests, but there were also performance tests. So they were testing non-verbal skills as well, which made them sometimes a little bit more useful than the Stanford-Binet tests, depending on what you were looking for.